All right, ladies and gentlemen, for this video, we're actually going to take a look at some of the properties that matter has. So you can see here on the screen, there are two types of properties that matter has. Now, I want to take this opportunity to remind you that matter are everything in the universe that's made up of atoms in the form of different elements. And you can have pure matter or mixtures of matter. And you can have matter that's just atoms and elements, or you can have matter that's combined into molecules. And what we're going to talk about is actually applies to all of those things. So it doesn't matter if it's an atom and millions of atoms. It doesn't matter if it's one atom. It doesn't matter if it's a molecule and it's millions of molecules. What we're going to talk about applies to everything. So matter, atoms, elements, molecules, compounds, they all have two types of properties, physical properties and chemical properties. And that there are two types of changes that matter can undergo, physical changes and chemical changes. Not an accident that these two things are similar. All right, the physical properties and the chemical properties and the physical changes and the chemical changes are all related. Now what we're going to focus on in today's video is the physical changes. So, that looks weird. Now, what's most important is that the physical change in matter is a change where the matter's composition is not altered, okay? And that's really important to understand, is that it's not altered, all right? So the physical composition doesn't change. So what does that mean? That means that the numbers and types of atoms and molecules in the substances do not change. If I have water undergo a physical change, when I'm done with it, it's still water. If I have a log, which is made up of all kinds of carbohydrates and lipids and probably some water, all right, if it undergoes a physical change, when it's done, it's still made up of carbohydrates and lipids and some water, all right? That's really important. The idea that the numbers and types of atoms and molecules do not change, all right? They do not change. That's the key for a physical change. Is the substance still made of the same atoms and molecules? Now, one of the ways that we can tell this is that physical changes can often be reversed. For instance, when I freeze water, the liquid form turns into ice. Can I melt ice? Of course I can. And so since I can reverse it, that means that it's still a physical change. It's still water. Like that part hasn't changed. A couple of examples. Split wood. Take an axe, cut a log in half. It's still a log. Yes, I cut it in half. But if I look at the two halves together, the numbers and types of atoms and molecules in the substances are still there. Yes, it's split into two pieces, but the numbers are still the same. If I take a rock and smash it with a hammer, yes, it's going to be a pain to find all the pieces. But all of the atoms and molecules and compounds in that rock are still there, even if they're spread out in smaller bits. Same thing with chopping. Now, I know you're thinking to yourself, well, you already said splitting wood, but couldn't you chop an apple? Couldn't you chop an onion? All right? Couldn't you chop a steak? And guess what? If you cut it, it's still an apple. It's just an apple in multiple pieces. It's still an onion. It's just an onion in multiple pieces. It's still a steak. It's just a steak in multiple pieces. And that's important to realize, that what's going on here is that these things are remaining the same because the numbers and types of atoms and molecules are not changing. That's the key for a physical change. And one thing to think about is they can often be reversed. Yeah, you cut a log in half. You really can't undo that. You could glue it back together, you know, or you could sort of comprehend that the log is still there. It's just in two pieces. Whereas if I burn a log, I'm never getting that log back. Okay? That's a key idea for all this. Now, one of the big things about physical and chemical changes is all about the states of matter. Now, we talked about this in a previous presentation, but matter can be a solid, a liquid, or a gas. And matter can transition from solid to liquid, from liquid to solid. All right. Matter can transition from liquid to gas or gas to liquid. Matter can transition from solid to gas or gas to solid. Okay? And when it does that, it's either melting, or it's freezing, or it's boiling. We like to say vaporizing. Or it's condensing, which is condensation. Or it's sublimating, which is sublimation. Or it's deposition. All right? Now, any of these changes are physical. And that's important, okay? It's important for you to realize that they're physical changes, because if I have, like I said, we said with water, if I take water and I freeze it, it becomes ice. But I can then take that ice and melt it, and it becomes the water again. The substance has not changed, okay? This is the key. The composition of this substance has not changed. It's still water, just water in a different form. Now, the harder one to wrap your head around is when I boil water, because it becomes what you think of as steam. But that's still water. It doesn't become something different. And if I was able to capture that steam and put it in like an icy bath, it would become water again. And now, obviously, that's a challenging thing to do. We have to set up equipment and make sure that we boiled it properly, but it still can be done. And that means that it's a physical change. All right? So this is a really key point here. Altering states of matter are physical changes. Okay? Altering the states of matter are physical changes. Now, the last thing we want to talk about is physical properties. Now, properties of substances are important because we want to know what properties a substance has because of its atoms or because of its elements. And so to understand that, before we can get into the different properties that different elements have, we have to understand what are physical properties and what are chemical properties. So physical properties tend to be very qualitative. We use that word quality. You observe them or measure them. Now, when you observe them, you use all your senses. Obviously in a lab, please don't taste anything. But in real life, you can. You could taste an apple and use that as a physical property. All right? Now, when you do a physical property, you observe or measure it, and this is the key, without changing it. If you change it into something else, you're not looking at a physical property. So down here I have this list of physical properties. Something's color. You can look at its color. You don't have to change the substance. My car is blue. Well, there we go. I know what color the paint is. That's a physical property of the paint. I didn't have to do anything to the car to observe that. Texture, what something feels like. Again, you don't have to change it to look at that. Odor, all right? You don't have to change it to smell it. Luster is when something is shiny. So if it is lustrous, it's shiny. If it's not lustrous, it's dull. And whether you have luster or not is a physical property. Now, we talked about this in the last slide. Melting, boiling, freezing points, the state of matter you're in, those all are physical properties. Okay? Density is a physical property, and we're going to talk about this in some detail. But density is something's mass divided by how much volume it takes up. So like paper, real low mass takes up a lot of volume. A small rock, real high mass takes up not a lot of volume. And there's a relationship between mass and volume that is a physical property. And that's something we call density. Solubility is what liquids something mixes with? Like, sure, I want to put salt in water. There you go. Salt is soluble in water because we all know that you can mix salt in water. But that is still a physical change because if I need to, I could separate that salt from the water. It's not easy. I have to boil off all the water. I have to make sure I capture the salt. But I can. That's the important part. Hardness, again, you can tell how hard something is by whether you try to break it or not. All right. Conductivity, which is probably going to sound obvious, but I feel it needs to be said. It's whether something can conduct electricity. And we'll get into why things can or cannot conduct electricity, but it's important to understand that is a physical property. Also, malleability, which is whether it's flexible. Piece of string, very malleable. Ruler, not so malleable. Trying to think of something else that's very flexible. But anything that you can bend, all right, or twist into a different shape, that's malleability, all right. And the last one that I want to add here is ductility. And that's the ability to spin something into a wire. If you think about all the little thin wires we use in electronics, which is, obviously a huge part of our society. If you think about, if you ever play with Play-Doh and you just start rolling it in your hands, you know how it starts becoming like a hot dog and then like a long string. Well, there are substances in nature that you can do that with. We actually use them to make wires, and that's what ductility is. All right, so here we have a presentation on the physical properties that matter has and the physical changes it can undergo and what exactly makes something a physical change instead of a chemical change.